Hello. Yeah. Hello, everyone. My name is Praveen Kumsagi. This is Siddharth Gogar. We are from Cloud and Communication Solutions Group at Flex. In this session, we are going to talk about validation of CORD SEBA reference design on the OCP platform. In the next 15 minutes, we are going to show how Flex is engaged with OCP, ONF, and AT&T to deploy and validate CORD SEBA stack to our Open Engagement Lab. As Chris Winslow mentioned in one of the earlier keynotes, Flex is involved with design and manufacturing of compute, storage, and networking modules ranging from core data center to the edge. In this talk, we are going to focus on edge data center called software stack called CORD. CORD stands for Central Office Re-architected as Data Center. When it comes to building open hardware, Flex has designed various open compute racks and storage servers, and also does OCP-based system integration by utilizing OCP partner designs. We are also actively involved with various open source software consortiums where we deliver open server and rack management software solutions. Lastly, we have a Silicon Valley design center where our hardware and software engineers come together to deliver and validate integrated hardware and software solutions for our customers. With our Open Standard Engagement Lab, we are able to share our rack deployments with our customers, partners, and fellow open hardware and software consortium members. We have partitioned our lab into multiple isolated pods for different communities, partners, and customers, depending upon the requirements. Our software team has developed a tool called FAST, which stands for Framework for Automated System Testing, which helps us to validate and deliver racked hardware and software solutions, and also any new software changes around OpenBMC or Redfish or other software implementations are well tested. Now my colleague Siddharth Gogar is going to talk about CORD and SEBA pod.
Hi, my name is Siddharth, and I would be going over through journey of Flex and CORD. So before starting what SEBA is, I would like to show how Flex has been involved with the CORD project and its multiple reference design. We joined ONF in second half of 2016, where we were exploring what CORD is, and we're doing a single node deployment. Then we upgraded our fabric to a 10 gig fabric with a manual deployment. Later on, we had more automation built into the CORD deployment and upgraded our fabric to a 40 gig fabric network. Once we had a full-blown CORD environment up and running, we opened a CORD community lab where we partnered with multiple partners such as Spirent and Polaris in having some joint solution done on top of CORD. In first half of 2018, we also submitted a CORD 5.0 QA reports and did an OCP-based multi-node CORD deployment validation. And since second half of 2018, we have been working on contributing to CORD certification program and demonstrating SEBA workflow on multiple Flex platforms as well as OCP platforms. So using our Flex engagement lab, we have been supporting ONF in his reference design. The first one to mention is the Tralis openEDGE platform, and the second is the CORD SEBA, and that's running on an OCP hardware. So let me introduce you to the SEBA architecture, which our friend Saurabh just explained. I would just give a quick overview of the architecture. In general, in a CORD, in SEBA, there would be a single management switch, which is connected to components such as aggregate switch, compute nodes, OLTs. There would be up to 16 OLTs on a single SEBA pod, and each of these OLTs can support up to 64 ONUs. So that's how you can scale your SEBA platform. On the compute nodes, there would be multiple virtual gateways and abstract OLTs, and all of these instantiated. And on the external LAN, there would be services such as BNG, DHCP server, Redis server, external OSs, and public internet for OSs and BSCs and all of these connections. in SEBA, there are multiple important components. The first one to point out is the OLT, which is an OCP accepted design. These OLTs are the ones which connect the residential gateways or the ONUs to the central office network, which is the SEBA right now. So these OLTs are based on Broadcom, Strata, DNX, and PON system on chip. In terms of the SEBA architecture, at Flex, we have a subset of the SEBA architecture which was defined earlier with 4 OCP servers, single OLTs, and 1 40 gig aggregate switch. There are 4 ONUs connected to the edge core OLTs, which are serving the subscribers. All of these are connected to ONF Jenkins environment for auto deployment and validation. The servers over here are from our partners, MyTech, which are OCP accepted designs, and the switches from Acton Edge Core, which is also an OCP accepted design. So that's how this entire architecture is based on an OCP accepted designs, right from the OLT, the Edge Core switches, and also the compute nodes which are mentioned here. Now let's go to what is the software stack which we are using over here. As mentioned by Saurabh about the open source software stack, here we are using the SEBA, which has multiple components such as Ubuntu for base operating system deployment. There is a Kubernetes server for service orchestration, and there are multiple agents such as XOS, Volta, ONOS, and all of these running on top of the Kubernetes. And then there are subscriber traffic, which are the end-to-end application. And in terms of the switching, it's the leaf spine trellis network, which is supporting the SEBA. So at Flex, we are doing a full stack deployment validation of the SEBA. This starts from first validating the servers using a test-based deployment. We are using the FAST framework, which is built by, which is a homegrown software framework for testing and validating servers. The first part of the server validation is doing benchmarking of various CPU, memory, network, and system performance. Once we have validated the hardware spec, the next step is to validate the network port speeds of each of these servers to check if those are operating at optimal speed. Once that is done, we use MAS for the operating system deployment, which is Ubuntu for SEBA. And then we do Ansible, using Ansible and Kubernetes, we do a Kubernetes deployment for the cloud infrastructure deployment. And once we have a Kubernetes cluster up and running, we deploy core using ONF Jenkins environment. And once we have a base SEBA deployment done, then we are using robot framework for validating the SEBA with various workflows. So in terms of SEBA, what we are validating is the fast part. In general, when a subscriber, before SEBA, the subscriber traffic was being processed by VNFs, which were hosted on the compute nodes. This is what was introducing latency in the part. But with SEBA, there is a fast part available where subscriber traffic goes to an ONU, then to an edge core, and then to an aggregate switch, and then to to the backbone network. So this is how you can achieve, this is what is called as fast path in a SEBA. So here we are validating fast path with multiple scenarios which any service provider will encounter. Those are all documented in documentations which are called the FCAPs. So here you can see the SEBA test plan, which is developed by ONF. It's a comprehensive test plan which consists of various test cases as per the FCAPs documentation from AT&T, describing the workflow of a SEBA pod. So here I would demonstrate a few of the test cases, such as the fast part, which was described earlier, end-to-end ping from the subscriber to the backbone network. As you can see here, there is a subscriber traffic, and then there is an OLT, which directly goes to a switch fabric, and then to the backbone network. So this is what is meant by the fast path, and we are able to validate those using the end-to-end ping connectivity test, which is one of the SEBA test case one. Let's get deeper into the second test case, which is, let's say there is a scenario where a subscriber traffic is running. Then using the XOS, we remove the ONU from the whitelist. And as soon as that is done, you will observe that the subscriber traffic is blocked now. Now, again, we re-add the ONU in whitelist. You can see the subscriber traffic is passing again. So this is how you verify the end-to-end connectivity test with ONU not in whitelist and ONU in whitelist. So as mentioned earlier, all of these environment is integrated with ONF Jenkins for continuous deployment, which includes multiple steps such as installing Kubernetes cluster, then installing ONOs, installing Volta agents, and all of these, and then configure the RCOD pod with the OLT components in it. Once the deployment is done, the next step is to do the automated validation using the robot framework over here, and all of the test cases which I described earlier has also been automated, and those are running. As you can see, once we have a SEBA test automation done, you can observe that it takes around 1 hour to run the entire test case. And the result summary would show all of these current 10 test cases which have been developed and validated. And further logs could be established using the robot framework, where you can dive deeper into each of these test cases and see where what's the actual traffic which is going from the subscriber to the backbone network. So going forward with this engagement using our Flex Engagement Lab, we would continue working with the Core QA group to develop the comprehensive test plan and validate it. We would also continue working with ONF Certification Brigade in its development and execution. And we would like to extend our FAST framework to do more validation of multiple reference design of ONF and also for edge compute use cases. And moving forward, we would also like to collaborate with more service vendors, more providers to develop more white papers and do more comprehensive test plan validation using Flex Engagement Lab. So any questions around this, and for collaboration, please contact me using this link or contact me on my email. Any questions?
You mentioned you're using an Edge Core OLT.
Yes.
Specific ONU that you use as well?
Right now, the ONUs which we are using are the alpha from the alpha networks, and those were the ones which were recommended by ONF. And there are, like, if you go on the ONF website around SEBA, you can find more vendors of ONU.
I have a question. Meaning, this is great that you guys are doing the validation and the engagement, with your engagement lab. I'm asking this on behalf of the OCP Telco group also. As we have new specifications and new hardware, right? Meaning there are ODMs building, say, newer hardware. We have some FPGA work going on. So when they bring in, how do you see this collaboration between OCP and, meaning in terms of SEBA, right? How would you help, or what is the value that you would provide to those ODMs?
In terms of like our use case over here, our value proposition is to have more often validation done in the lab trials and all. So that's what our current the focus has been, working with these consortiums to develop the POCs and white papers around those. And then it's up to the marketing group how they want to take towards this to the actual service provider deployment. That would require a more broader level of engagement with the companies involved. So as of now, with this Flex Engagement Lab, what we are trying to do is have Flex hardware or our partners' hardware work with various open source consortiums in getting their software stack validated in these types of open reference platform or our own internal platforms. So that's what our using the Flex Engagement Lab, which was described earlier. 1 second. Yep. So we have segregated our lab into multiple pods, which are each serving one of the reference stack. So I hope I answered your questions. Yeah.
No, I think that's good. Meaning, I know you're more on the software, right? Meaning that's kind of what.
Yeah, I'm more
us-
on the engineering side,
Right.
doing more of validation.
I think
now, yeah.
what the community would like to understand is, I mean, I have heard this from a few ODMs on, how do they get engaged? So maybe that's something that, we could talk offline.
As of now, all the engagement has been working with the communities, and
Okay.
when we see some exciting project and we have our own internal interest, that's how we have been involving with the consortiums.
Okay, thank you.
Okay, thank you.